So sometimes in mathematics, we find different approaches on the same subject. I have here two textbooks. One is, the Principles of Differential and Integral Equations by Corduniano. The other one is an Introduction to Differential Equations with applications by Brouwer and Nohel. So like I said, both treat the case of differential equations, but the approaches they take is totally different. So let's start out by taking this book down here by Corduniano. So I bought this book in 2012, so 10 or 11 years ago. Principles of Differential and Integral Equations, Corduniano. This person was a teacher, a professor at the University of Jassy in Romania. So he's a Romanian author. It was printed in 1971 by Allen and Bacon in the USA down here. So look at the topics down here. I wanted to share with you the topics because it's a wonderful textbook actually. Elementary methods to solving the linear equation of the first order. So a first order differential equation, separable equations, exact equations, and then a little bit about the uniqueness problem down here. A few examples down there. Then they move on to the existence of theory, the existence theory for differential equations. One of the main problems, if you will, one of the central problems in differential equations is the study of the uniqueness and the existence of solutions of differential equations, actually. Some global problems. So they tackle here in chapter 3 here, they tackle the existence of global solutions. And it's a super nice subject, actually. Some special classes of differential equations, some stability theory, Volterra equations, Fredholm theory, then some beautiful things, actually. So here in chapter number 9, you find some stuff about, oscillation. This is what they call the Sturm oscillation theorem, Sturm theory. Maximum and minimum solutions of the scalar differential equations, and a theorem of Massera, actually. If you scroll through the textbook, actually, you find that it's got a super theoretical flavor. Some integral inequalities down here. This is one of the few textbooks, textbooks I have come across where actually they prove the Grunwald's inequality. Lemma here, Grunwald's inequality. It's a super useful inequality to estimating some of the solutions of your differential equation. Bihari, lemma by Bihari down there. And as well, they have here a set of problems. As you can see, like I said before, it's got a strong theoretical flavor down here. So I'll be teaching differential equations this coming term, spring 2023, and I'm going to be using this textbook for pretty much the second part of my class down here. Look, consider the differential equation down here. So x dot equal f of t and x with the initial condition x at times t naught equal x naught, where f is continuous on this, square down here or rectangle, and such that blah, blah, blah. So there's a sort of, it's not a Lipschitz condition, but there's a condition involving a function phi, such that there's a certain integral condition for phi, then the solution of this problem is actually unique. So this is a unicity result on solutions, actually, of 2, 3, and 2, 4. So the equation along with the initial condition. So it's a beautiful thing, actually. There's the proof down here with a little bit of mathematics, background, you can understand no problem the proofs of, displayed here all along the textbook. It's a wonderful textbook actually for people with a certain background in differential equations actually. And the most important thing is that you get to enjoy the reading actually. It's a wonderful textbook by Cordoniano. If you have the chance to, grab this textbook to purchase, to buy this textbook, actually do it, because it's actually a wonderful thing. And then we have differential equations with applications. So this one, as the title suggests down here, it's more applied. So it's, well suited for engineers and stuff like that. Applications here, some applications to physics. It's a nice textbook as well, but I prefer the theoretical stuff actually. Some simulations down there. Well, let me tell you, myself, I get a little bit like, ugh, when I see these tables and stuff like that. It's like, it doesn't encourage my interest. That's what I wanted to say, because I know there's some numerical stuff there involved, some numerical computations and iterations and all that stuff, and that, wow, it's like, I don't want to get there. So even though it's a nice textbook, you have to be aware that this is more suited, little, pointing toward the engineering line there for people who do actually some perhaps computational simulations and stuff like that. It's a nice textbook anyway. Lots of problems here, exercises down here, 1, 2, 3. So what do you have to do here? So you have an initial value problem for a first order system in vector matrix form. So what do we have to do? So we have to write, okay, an initial value problem for a first order system in vector matrix form. So here you are given the equations, so you have to put the equation and the initial condition into a vector matrix form. Stuff like that. Linear homogeneous systems down here, and so on. So guys, in math, plenty of choices for whatever floats your boat. If you are of a more theoretical nature, right, you can pick up the textbook by Cordoniano. If you are more like, if your interest is geared toward applications and engineering stuff, there's the textbook by Brouwer and Nohel as well. So in my next video, I'm going to talk about tensor analysis, because I have there 2 books about tensor analysis, and the approach is totally different as well. I have plenty of books there to talk about. So I'm going to be making more of these videos very, very soon. Thanks so much for watching, guys, and take care. See you in the next one.